Hello dear viewers, this is AI Voice Gary, speaking to you as Buddy from Town's narrator. Since Buddy began his exploration of the cosmos, he has become interested in current news about the universe. Today, Buddy from Town is sharing news about a supernova. Posted on the NASA website on December 17, 2021, with text provided by the European Space Agency, ESA, NASA shares news about Hubble viewing a galaxy with an explosive past. The NASA ESA Hubble Space Telescope captures a side-on view of NGC 3568, a barred spiral galaxy roughly 57 million light-years from the Milky Way, located in the constellation Centaurus. In 2014, the light from a supernova explosion in NGC 3568 reached Earth. This supernova is a sudden flare of light caused by the titanic explosion accompanying the death of a massive star. The supernova was discovered by amateur astronomers, who are part of the Backyard Observatory Supernova Search, in New Zealand. The ESA explains, this Hubble observation comes from a wealth of data gathered to pave the way for future science with the upcoming NAS, ESA, CSA James Webb Space Telescope. By combining ground-based observations with data from Hubble's Advanced Camera for Surveys and Wide Field Camera 3, astronomers have built a treasure trove of data on the connections between young stars, and the clouds of cold gas in which they form. One of Webb's key science goals is to explore the life cycle of stars, particularly how, and where stars are born. Since Webb observes at infrared wavelengths, it will be able to peer through the clouds of gas and dust in stellar nurseries, and observe the fledgling stars within. Webb's superb sensitivity will even allow astronomers to directly investigate faint protostellar cores, the earliest stages of star birth. A supernova is a large explosion that takes place at the end of a star's life cycle. A star explodes every second or so somewhere in the universe. A supernova happens where there is a change in the core, or center of a star. A change can occur in two different ways, with both resulting in a supernova. Type I supernova. The first type of supernova that happens in binary star systems. Binary stars are two stars that orbit the same point. One of the stars, a carbon-oxygen white dwarf, steals matter from its companion star. Eventually, the white dwarf accumulates too much matter. Having too much matter causes the star to explode, resulting in a supernova. Type II supernova. The second type of supernova occurs at the end of a single star's lifetime. The star runs out of nuclear fuel, some of its mass flows into its core. Eventually, the core is so heavy that it cannot withstand its own gravitational force. The core collapses, which results in the giant explosion of a supernova. Supernova add enriching elements to space clouds of dust and gas, further interstellar diversity, and produce a shock wave that compresses clouds of gas to aid new star formation. But only a select few stars become supernova. Many stars cool in later life to end their days as white dwarfs and, later, black dwarfs. Stars and star formation. The study of the birth, life, and death of stars is central to the field of astronomy. NASA explains, stars are the most widely recognized astronomical objects, and represent the most fundamental building blocks of galaxies. The age, distribution, and composition of the stars in a galaxy trace the history, dynamics, and evolution of that galaxy. Stars are responsible for the manufacture and distribution of heavy elements, such as carbon, nitrogen, and oxygen. Their characteristics are intimately tied to the characteristics of the planetary systems that may coalesce about them. Star formation is the process by which dense regions within molecular clouds in interstellar space, sometimes referred to as stellar nurseries, or star-forming regions, collapse and form stars. Stars are born within the clouds of dust and scattered throughout most galaxies. If a cloud is massive enough that the gas pressure is insufficient to support it, the cloud will undergo gravitational collapse. As the cloud collapses, the material at the center begins to heat up. Known as a protostar, it is this hot core at the heart of the collapsing cloud that will one day become a star. The mass above which a cloud will undergo such collapse is called the gene's mass. The gene's mass depends on the temperature and density of the cloud, but is typically thousands to tens of thousands of solar masses. During cloud collapse, dozens to tens of thousands of stars form more or less simultaneously, which is observable in so-called embedded clusters. The end product of a core collapse is an open cluster of stars. Key elements of star formation are only available by observing in wavelengths, other than the optical. The protostellar stage of stellar existence is almost invariably hidden away, deep inside dense clouds of gas and dust left over from the giant molecular cloud. Often, these star-forming cocoons, known as Bok globules, can be seen in silhouette against bright emission from surrounding gas. Early stages of a star's life can be seen in infrared light, which penetrates the dust more easily than visible light. This concludes Buddy's Space News today. If you would like to follow along to see Buddy from town become Buddy of Singularity, please click subscribe and a like would be appreciated. Until next time, dear viewers, keep looking up and looking back, way back.